Hello everyone. Hello. Does it work? Oh yes, okay. Okay, so I propose to discuss about pricing. Insurance pricing is one of the key elements of the value chain of insurers, and it will change dramatically thanks to big data and data science. So I wanted to highlight how it changed and to give you some flavor about what it is about. First thing, the traditional way to do insurance pricing. It's an article of The Economist. Insurers have traditionally used crude demographic data such as age, location, sex, to separate the testosterone-fueled boy racers from their often tamer female counterparts. So basically, insurance pricing on motor is really to split between those who are driving safely from those who are really not. And it's, yes, effectively a lot about testosterone. So how we do that? We generally look at the car and look at the person. And so, for instance, if you have a car such as the Mean Machine with someone inside that is a male and quite aggressive, we will ask him 1,000 euro as a premium. If it's a woman, 400 euro. And if it's an old car with someone driving very safely, we will ask him 200 euro. The way we assess that for years is the traditional statistical method is the GLM, or logistic, according to the kind of risk. But basically, we are doing linear regression of Poisson or gamma process. But the world is changing, and pricing is becoming more and more strategic. I just wanted to highlight how it works in the UK, probably one of the most sophisticated market in insurance in the world. Our company there receive millions of quotes a day. So every day we have to quote millions, and when I say millions, it's really impressive. And for each of these quotes, if we are able to price $1 or $5 below, we have the deal, or we don't. So it's really very sensitive to price. And so there, the old way just to ask about age and to ask about the car is not sufficient. We have really to improve our way to do pricing. So the way we do that is really to extract all the value we have from data. Obviously, we have internal data, the data about the age of the kind of demographic information, but we try also to use external data about the location of the person and a lot of information. We try also with features engineering to extract more value of the data we have already. And we try also to extend the information that is provided by our clients. One of these is called telematics. Is basically we put in the car a device that will record every event of the car. So, for instance, you accelerate, you brake, you corner very fastly, then we record the location and the time of this event. And obviously, if you are a very bad driver, it's not useful, but if you are a good driver, and you are not in the good demographic square, this will help you to have a significant discount. For instance, you are a young male. Thanks to that, you can have a discount because you will be priced if you drive well, as your driving behavior is. So, for insurance, it's really a significant shift. We used to work with a lot of data, but if you look the blue line, it is a volume of traditional pricing information. So we speak, for instance, for progressive insurance of gigabyte. When we add all the information of how you drive, so telematics information, then we enter terabytes. So for instance, progressive insurance, they have reached 100 terabytes 1 year ago, of information about the way people drive. So we are really not into only smart data, but really about big data. After that, the question is how I can use this information, because we have a lot of information about the driving habit, but the number of claims stay really limited. The frequency of an accident is 1 every 10 years, more or less. So you have every 2 seconds an information, an event, and you have an accident every 10 years. So we have a lot of information, but to characterize which information is relevant to predict claims, it's very limited for the training part. It's very limited as an information. And this is really the issue we face. So what we try to do first is to limit this huge information into scores or features that will try to capture a lot of this information. So for instance, we study here, you have 2 persons and we study their cornering, so how they accelerate turning, left or right. And we can see in blue and red that we have 2 different persons, one that is much safer than the other one. And so we will use all this information and synthesize all this information into only 5, 6 scores. And in that way, it will be practically, we will be able to predict the claims. So then when we have done this score, we have a corner score, we have a brake score. For instance, Progressive Insurance, they drive according to when you drive, how you brake, the number of kilometers you are doing every year. This is okay if you include some external information, such as what was the weather. Obviously, the speed is interesting, but if it was wet or dry, it's not exactly the same information. The type of street, if you are at 70 kilometers on a motorway or on a road, it's not the same thing. So we have to complete with external data all these scores with the weather, with the map, speed limit also, which is sometimes complex to extract. And then when we have our score, we can try to predict which kind of score will be predictive to the claim frequency. And so there we use traditional methods of machine learning, so random forest, gradient boosting, GLM, we keep it. And thanks to that, we were able to find the right scores that predict the claim frequency. Here, what is interesting is, in fact, it's a mix of score. It's not a unique score that predicts the claim frequency. You have some score that derives from your driving style, such as brake. You have some score from more the type of roads, the mileage, the number of kilometers you drive, and when you drive also. For instance, when you drive by night, it's really it's very predictive of claims frequency. So we have a way of actually identifying better drivers. That is a huge advantage, definitely. It was what was written by Progressive Insurance, to be able, within our portfolio, to see which ones are good and which ones are less good is really an advantage. Let's look at the measure, thanks to this information, what we are able to explain. This is slide from Progressive Insurance. So the way we do that is with Lorentz curve, probably most of you know. So basically a curve where we order the high risk and the low risk, and we try to, according to our premium, and we try in a cumulative way to see their losses. So basically, as the high risk are here and the low risk are here, we expect, if our pricing is very good, to have a curve that will be very high and left. Here, you can see all the curve of pricing of Progressive Insurance. And that was in 94, and they have improved each and every year, and currently their traditional pricing is here. So you can see that with traditional method, with external data, you can significantly improve. And thanks to telematic, you are there. You are so telematic, you have gained that. This is huge, because it's basically equivalent to 5 years of pricing research. But there are still a lot of risk that is not explained. Perfect pricing, the pricing that we all love, that will explain basically you will have tomorrow claims. This curve is here, but we are far from this perfect curve. So there are still a lot of risk despite all the information we inject. So hazard remains. This is in a way good for insurers, because otherwise we will have Google that will take the job instead of insurers. But we have still a lot of hazard remaining. As a conclusion, our experience with telematic, we are one of the major telematic insurer in Europe, is that thanks to telematics, we can see a real change in behavior for the people who have this kind of device in their car. This has been explained by a Nobel Prize of Economy, Kahneman, that when we know that we are tracked, monitored, we tend to use what is called the system 2, and this system 2 controls more, and we are less selfish due to that, with more attention. The cost of telematic will decrease, and so more and more people will be able to have that, to have a rebate if they are a good driver. But to do that, we really need data science. It's hugely, as a consumption, we need a lot of good and very good data scientists in order to extract all the value that we have now. And we have already several Belgium actuaries and data scientists that are working on telematics, and we are very happy with them. And so if you have now the taste to see how insurances and telematics, let's discuss. That's it.
So you will probably not believe this, but we are still on time. We are still even about 15 minutes early. So we are going to finish early, allowing you more time to network together, spending some time discussing all the different issues that you've seen today. Don't forget to be here on time. We will try to start early. Yeah? If we leave early, why don't we, instead of starting at 2, start at quarter to 2? Yeah? 15 minutes early. And so let me please invite you to the lunch. The lunch has been offered by our friends from Proximus and our friend from Base 3. Without them, we wouldn't have any food on our plate. So have a good lunch and see you at 13:45. Thank you. Bye-bye.